Imagine a computer so powerful it could solve problems in seconds that would take today's supercomputers millions of years. Sounds like science fiction, right? Well, welcome to the wild world of quantum computing, a technology that's inching closer to reality and could change everything from how we secure our data to how we discover new medicines. Today, in 2025, the year of quantum science and technology, we're decoding quantum computing for you. No PhD required, so grab a snack, hit that like button, and let's dive into the future. Let's start with the basics. You've heard of regular computers, right? Which you use every day in your house, like your mobile phones or your desktop or even your laptops. They use bits, tiny switches that are either zeros or ones. Everything you do, watching this video, scrolling social media, boils down to billions of these zeros and ones. But quantum computers, they play by different rules. Instead of bits, they use something called qubits, quantum bits. Well, I'll make it easy for you. Think of a qubit like a coin flipping in the air. Before it lands, it's not just heads or tails. It's kind of both at once. That's called superposition. And it lets qubits be zeros, one, or mix of both simultaneously. Why does that matter? Because it means quantum computer can explore tons of possibilities at the same time. Unlike a regular computer that checks one option after another. And here's where it gets weirder. Qubits can be entangled. That's when two qubits become like quantum twins. If you tickle one, the other jiggles instantly, no matter how far apart they are. Scientists call this spooky action at a distance, and it's superpower that boosts quantum computers' potential. How do you actually use these quirky qubits? Quantum computers manipulate them with something called quantum gates. Think of them as knobs and dials of a cosmic DJ booth. One gate might put a qubit into superposition, the other might entangle it with its body. But here's the catch. When you measure a qubit, that superposition collapses and you either get 0 or a 1. It's like catching that flipping coin. It's only heads or tails once you grab it. Its probabilistic nature makes quantum computing tricky but powerful. And in 2025, we're seeing big steps forward, like quantum error correction or QEC. Companies like Quantware are rolling out kits to fix mistakes in quantum calculations, and NVIDIA is even using AI to crack the code on errors. It's like giving these machines a spell checker, and it's a game changer. Now, let's talk about where we are today in 2025. Quantum computing's in what's called the NISQ era, Noisy Intermediate Scale Quantum. That's fancy way of saying we've got quantum computers with a decent number of qubits, like IBM's Osprey with 433, but they're still noisy, meaning errors creep in a lot. These machines need to be kept colder than outer space, near absolute zero, and shielded from everything. Even a stray radio wave. Back in 2019, Google claimed quantum supremacy, saying their 53-qubit system did a task in 200 seconds that'd take a supercomputer 10,000 years. IBM disagreed, saying it'd take 2.5 days, not years. Point is, we're making progress, but it's a bumpy ride. And the world's betting big on it. Investment hit over $2 billion in 2022, and it's still growing. Why? Because the first country or company to crack this could dominate tech, security, you name it. What's all this hype about? Let's talk applications. First up, cryptography. There's this algorithm called Source that could crack today's encryption, like the stuff protecting your bank account, way faster than any classical computer. Scary, right? You could lose your bank account any moment quantum computing is on. That's why folks are racing to build quantum-proof security. There's Grover's algorithm. It's like a super speedy search engine. Imagine finding a name in a phone book with 100 million entries in way fewer steps than flipping through page by page. Here's where it gets really cool. Quantum computing could simulate molecules perfectly. That means designing new drugs or batteries faster than ever. In 2025, we're seeing it help with quantum chemistry, calculating energies for huge molecular systems with crazy accuracy. It's not just tech, it's life-changing stuff. So, when do we get these quantum wonders? Well, hold your horses. It's still years away from being practical on a big scale. We need more qubits, better error correction, and ways to keep these machines stable outside super cold labs. It's a global race. China is spending 4 times more than the US, and companies like IBM and Google are all in. But the future's bright. Schools are teaching quantum basics to kids, and 2025's the year of quantum science and technology. Proof that it isn't just a fad. The first big breakthrough could mean better AI, greener tech, or even cracking mysteries of the universe we haven't touched yet. That's so cool, right? There you have it, quantum computing, decoding for dummies like us. It's a mixture of mind-bending physics, insane potential, and a few big hurdles. What do you think? Will it change the world in our lifetime? Drop your thoughts in the comments. Smash that subscribe button for more tech deep dives, and let's keep decoding the future together. See you in the next one.